What's up guys, welcome back to another video here at Chief Academy, and today we'll be going through similar shapes regarding area and volume. Please like and subscribe if you haven't already, because I promise you it is this easy. Our learn outcomes for today is to understand what the scale factor is for area and volume for similar shapes and understand how to use it. It's also to solve similar shapes regarding area and volume exam questions. So, what are similar shapes? Similar shapes have three components: linear, area, and volume, and we will focus predominantly on the latter two, whilst using our knowledge of scale factors we have developed as we have already gone through linear similar shapes. In this lesson, we will focus on solving similar shape exam questions and understand the scale factor for area and volume. So, as we've already gone through linear similar shapes, we already know that if two shapes are similar, the corresponding sides are in the same ratio and the corresponding angles are equal. When calculating a missing area, we need to calculate the area scale factor. When calculating a missing volume, we need to calculate the volume scale factor. So, the area scale factor is the linear square factor squared, and the volume square factor is the linear square factor cubed. Then you would use your square factor with the info given to you. So let's do an example so you can see how to do it. Once again, here's another Math Genie exam question for you to have a go at. Have a go, pause the video, and then pause when you've done. So, in our first question, two solid shapes, A and B, are mathematically similar. The base of shape A is a circle with a radius of 4 cm, and the base of shape B is a circle with a radius of 8 cm. The surface area of shape A is 80 cm squared. Work out the surface area for shape B. Now, if you want to work out the surface area of shape B, we need to work out the scale factor. So we do 8 divided by 4 to get our linear square factor of 2. We square it to get our area scale factor, which is 4, and then we do 80 times 4 to get our surface area, because this is the enlargement. So the surface area for shape B is 320 centimeters squared. The volume of shape B is 600 centimeters cubed. Work out the volume of shape A. Now, we already know the linear square factor is 2, so if we cube that, we get the volume square factor of 8. So we do 600 divided by 8, we get the volume of shape A. So the volume of shape A is 75. Most similar shape exam questions for area and volume will be a total of 5 marks, which are an easy 5 marks to get in your exam. Some area and volume questions can have a part A and part B that rely on each other. So it's important that you get part A right, because it could lead to your answer in part B being wrong. However, you will still be awarded method marks if the correct method is followed. The harder similar shape exam questions also require you to work backwards, so be aware when to do so. Here's another exam question for you to have a go at. Have a go, pause the video, and unpause when you've done. So, cylinder A and cylinder B are mathematically similar. The length of cylinder A is 4 cm and the length of cylinder B is 6 cm. The volume of cylinder A is 80 cm cubed. Calculate the volume of cylinder B. So, if we work out our linear scale factor by doing 6 divided by 4, we get our linear scale factor being 3/2. If we cube this, we get our volume square factor, which will be 27/8. Time this by 80 and we'll get the volume of cylinder B. So the volume of cylinder B is 270 centimeters cubed. Now it's time to have a go at some of the hardest exam questions you'll probably be asked on similar shapes regarding area and volume. Have a go, pause the video, and unpause when you've done. So, two cylinders, P and Q, are mathematically similar. The total surface area of cylinder P is 90 pi centimeters squared. and the total surface area of cylinder Q is 810 pi centimeters squared. The length of cylinder P is 4 centimeters. Calculate the length of cylinder Q. So, if we do 810 divided by 90, this gets us to 81 over 9, which equals 9. And we've just worked out our area scale factor, because they both include pi, so we can cross cancel the pi out. Square root 9, we get our length scale factor, which is 3. Then we do 4 times 3, we get the length. So the length of cylinder Q is 12 centimeters. The volume of cylinder P is 100 pi centimeters cubed. Work out the volume of cylinder Q and give your answer as a multiple of pi. So here, we use our volume scale factor, so we do 3 cubed, which is 27, then do 100 pi times 27 to get 2,700 pi. Here's another exam question for you to have a go at. Have a go, pause the video, and unpause when you're done. So, two cones, P and Q, are mathematically similar. The total surface area of the cone P is 24 centimeters squared, and the total surface area of cone Q is 96 centimeters squared. The height of cone P is 4 centimeters. Work out the height of the cone Q. So here we do 96 divided by 24, which is 4, and that is our area scale factor, meaning if we square root it, we get our length scale factor to equal 2. 4 times 2 equals our length. So our length, which is the height in this instance, so the height of cone Q is 8 centimeters. The volume of cone P is 12 centimeters cubed. Work out the volume of cone Q. So we know our length scale factor is 2, so if we cube it, we get a volume scale factor to equal 8. 12 times 8 equals our volume, so our volume is 96 centimeters cubed. And that, ladies and gentlemen, is the end of today's lesson. I did say it was that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I will see you in the next one. Goodbye.